I welcome you all for this lecture series on 4G and 5G communication networks. In this lecture number 28, we will briefly discuss about spectrum sharing. Spectrum sharing is a way for different communication systems like Wi-Fi networks, cell towers, or even small devices to share the same radio waves, that is, frequencies, to send and receive data. Since there is only a limited amount of these frequencies, spectrum sharing helps make sure everyone can use them efficiently without interfering too much with each other. It's like multiple people sharing a single highway but using different lanes and coordinating to avoid traffic jams. So everything runs smoothly for everyone. Additionally, spectrum sharing is essential because the number of devices that need to connect to the internet is constantly growing. From smartphones and laptops to smart home gadgets and even self driving cars, managing how they all use radio frequencies ensure everything stays connected and works properly. It also helps in reducing costs and making internet and communication services more accessible since sharing allows more efficient use of existing resources instead of creating entirely new one. That's all about the spectrum sharing. First, we'll see the efficient use of frequency spectrum in modern applications. And what is the demand drive for this? The increasing need for multimedia content and information processing in services like e-education, e-health, and coupled with the surge in mobile broadcasting and the widespread use of electronic gadgets has created a significant demand for efficient spectrum utilization. As more people and devices connect to the internet, the pressure on the available frequencies intensifies. And what is the need? New generation mobile broadband networks designed to accommodate higher data throughput rates require sophisticated spectrum management techniques. This is critical to support the fast growing demand for data heavy applications and ensuring that the available spectrum is utilized efficiently and effectively. And what are all the technologies in use? Advanced technologies have been introduced to enhance no, spectrum efficiency. For instance, line of sight that we are calling it as LOS communication systems have been extended to operate up to 100 gigahertz. Additionally, the miniaturization of electronic components and systems enables the use of multiple frequency bands within single devices, facilitating more dynamic and efficient spectrum sharing. Next, spectrum management and sharing dimensions. And what is the main objective of the spectrum management is the ultimate goal of spectrum management is to achieve optimal spectral sharing. This is essential to maximize data transfer capabilities as greater frequency sharing ensures that more information can be transmitted concurrently by different users within the limited spectrum. And the dimensions of spectrum sharing. Spectrum sharing operates across three primary dimensions. What are they? Frequency, time, and location. Frequency sharing involves the allocation and reuse of different frequency bands. Time based sharing manages across through time slots, and location based sharing organizes spectrum usage based on geographical regions, preventing interference. And collective use of spectrum, thus we are calling it as CUS, collective use of spectrum. The concept of CUS promotes the idea of sharing spectrum among multiple users simultaneously without recurring licenses. This approach increases spectrum efficiency and allows more flexible use. Techniques like frequency reuse in telecom networks and technologies such as FDMA, frequency division, multiple access, and TDMA, time division multiple access, exemplify the practical implementation of collective use of spectrum, that is CUS. Next is the spectrum sharing methods. And the method of sharing spectrum is horizontal spectrum sharing. This method allows all devices to have equal rights to access available spectrum. No device or user is prioritized over other, promoting a fair and equal opportunity for spectrum use. This approach is beneficial for networks that require uniform access for all participants. Next one is vertical spectrum handover only. In this method, primary users are given priority to access the spectrum. Secondary users can utilize the spectrum only when it is not being used by primary users. This prioritization ensures that essential or high priority services have reliable access, even though it may limit availability for secondary users. And the third method is the hierarchical spectrum sharing. Hierarchical spectrum sharing is a more structured form of vertical sharing, offering an organized system where access is granted based on an enhanced set of priority rules. It builds on the principles of vertical sharing, providing more nuanced and efficient spectrum allocation, especially in scenarios involving multiple tiers of user. Even though it has got various methods, it faces some challenges too. Sharing spectrum among homogeneous networks with these similar structures and needs, is relatively straightforward. However, as network becomes more heterogeneous with varying technologies and requirements, the complexity of efficient spectrum sharing increases significantly. This complexity requires advanced management techniques to ensure minimal interference and maximum efficiency. This is very, very important property. And this diagram, so the sharing of multiple headnet in which the spectrum is owned by the macro cells and shared with other tiers. And this illustrates a multi-tier heterogeneous network. This we are calling it as headnet for spectrum sharing, where the spectrum is managed and primarily owned by a macro cell. In this system, the macro cell's tier shares its spectrum with the lower tier networks such as microcells, picocells, and femtocells, enabling more efficient use of available frequency resources. This hierarchical structure facilitates improved data throughput and converge, especially in dense and high traffic areas. The macro cell oversees and coordinates spectrum access among the various tiers, ensuring minimized interference and optimized spectrum usage across the heterogeneous network environment. Next, see here the spectrum sharing techniques. And next, spectrum using SDR. SDR means software defined radio and cognitive radio. And the key milestones of this SDR and cognitive radio CR are the evolution of SDR and cognitive radio significantly enhances mobile communications. And the dynamic spectrum is possible in this SDR and SCR. Sharing improves efficiency, reducing costs associated with multiple frequency usage. And the functionality of cognitive radio, it detects channel occupancy and facilitates switching to vacant channels. And it regularly senses carrier signal for optimal usage and essential for emergency and public safety conditions where high spectrum demand is required. And the regulatory support of this SDR and cognitive, or in some countries, regulators promote dynamic spectrum sharing to meet public safety needs. Dynamic means adaptively we can change the frequency values. And here we are using the white space utilization, that is DV broadcasters repeat the same channel over the long distances to prevent interference. And the limited receivers in overlapping coverage areas present opportunities for more efficient spectrum use. And this diagram shows the dynamic spectrum sharing between active and passive users, and it illustrates how spectrum resources can be efficiently allocated between two types of users, namely active and passive. Active users are those who actively transmit and receive data, often demanding real time continuous access to spectrum for activities such as voice calls, video streaming, and data intensive applications. These users require more stringent quality of service QoS guarantees to maintain seamless communications. The next user is the passive users. On the other hand, do not actively transmit signals but may require spectrum across for purpose such as spectrum sensing, monitoring, and intermittent communication. They generally have more flexible requirements and can tolerate delays and variations in spectrum availability. And the dynamic, it represents what? Dynamic spectrum sharing mechanism depicted in the diagram shows that how the available spectrum is allocated adaptively to balance the need of both user types. Active users are given priority access when necessary, while passive users utilize the spectrum opportunity, ensuring efficient utilization without causing interference. This approach maximizes spectrum efficiency by dynamically adjusting access based on current demands and usage patterns. Next is spectrum sharing techniques and challenges. First one is the protective measure. The broadcasters tend to prioritize the protection of their signal transmission, often limiting shared usage to low power systems that minimize potential interference with existing services. This conservative approach stems from the need to maintain signal quality and reliability. However, as users build collective confidence in the efficacy of shared spectrum access, there may be opportunity to consider higher power systems in the future. This gradual shift could enhance the capabilities of mobile communications while still ensuring that broadcasters can protect their transmission integrity. Next is spectrum sharing models. The landscape of spectrum sharing is diverse, with various global approaches reflecting differing regulatory environments and market conditions. In many cases, spectrum sharing involves leasing airwaves with the licensed service areas for a specified duration. This model allows multiple licenses to utilize the same frequencies, leading to more efficient network design and service delivery. The techniques employed can be administrative, technical, or market based, including spectrum leases and trading, which enable flexible arrangements that cater to the needs of different users while optimizing the overall use of available spectrum. Next, dimensions of sharing. And the spectrum sharing can occur across several dimensions, including time, space, and geography. By allowing multiple users to access the same frequencies at different times or from different locations, it becomes possible to maximize the utilization of the available spectrum. Additionally, power limitations can be strategically employed to enhance sharing potential, ensuring the low power devices and operate within the same spectrum without causing harmful interference. This multidimensional approach supports the efficient allocation of spectrum resources among various users. Even though it has got these many techniques, we are facing some challenges also in spectrum, challenges in spectrum management, or despite the advancement in spectrum sharing technologies, several challenges persist in spectrum management. Achieving the right balance between innovative technologies and market based method is critical to realizing the full potential of dynamic spectrum sharing. Moreover, effectively managing interference remains a significant challenge as it cannot be completely eliminated. Developing robust interference management model that supports sharing under different regulatory framework, whether administrative, market-based, or common-based, continues to be crucial requirement for spectrum managers to ensure efficient and equitable spectrum utilization. Next, administrative sharing of spectrum. Administrative management of spectrum sharing is the regulatory process that defines where and how spectrum sharing should take place. This involves setting rules that governs the performance of radio system, specifying technical standards, and approving equipment types to ensure efficient and equitable use of spectrum. Next, the policy establishment. Regulators should establish clear policies that facilitate spectrum allocation and licensing based on market demands. This involves creating fair, efficient, and transparent processes for awarding licenses, which may require evaluating existing spectrum allocations to determine how much can be shared or used on a non exclusive basis. Spectrum audit. Conducting an independent audit of spectrum holding is essential for regulators to identify bands that can be immediately repurposed for sharing. This process allows regulators to access current usage and to pinpoint opportunities for optimizing spectrum access and efficiently. Next is stakeholder consultation. Engaging stakeholders through consultations is vital for gathering the necessary information that informs decisions about spectrum sharing and the technical standards. By involving various parties, regulators can better understand the needs and concerns of user, which can lead to more effective and accepted sharing arrangement. Next, negotiation encouragement. Encouraging solutions based on negotiation between affected parties can affect and help facilitate spectrum sharing. This approach may include agreements on compensation, which can smooth the transition to shared usage by addressing the interest of all stakeholders involved. Next is specifications and incentives. And the regulator should establish specifications that promote the use of spectrum efficient technologies. Implementing mechanisms such as spectrum fee incentives can motivate users to transition their allocations and assignments toward more efficient usage, ultimately enhancing the overall effectiveness of the spectrum management process. So, the next sharing is the market based sharing of spectrum. Market-based sharing approaches such as auctions and spectrum trading are designed to maximize the economic efficiency of spectrum usage by enhancing the value extracted from available frequencies. These methods are generally preferred over administrative approaches, particularly when there is high demand for spectrum and rules governs its use are clearly defined. This market-driven strategy encourages competition and innovation among users, leading to more effective allocations of spectrum resources. How we people are using the Jio or Airtel or this Aircel, right? So many competitors are there, no? Spectrum licenses. Market methods are prominently employed during the initial issuance of spectrum licenses, primarily through auction process. Auction allows for competitive bidding, enabling various entities to place bids for the frequency they seek. This competitive environment ensures that the spectrum is allocated to those who value it the most, thereby optimizing the use of available frequencies and promoting overall efficiency in the market. Next, trading. The market based methods enable the buying and selling of spectrum rights during the license lifetime, facilitating adoptable and efficient spectrum use. And scarcity and price mechanism. Efficient allocation relies on market pricing with well designed auctions, ensuring frequencies and are assigned to firms that value them the most, promoting optimal usage. So this is also very, very important property. Well designed and effectively managed auctions play a crucial role in determining the market values of frequencies, as they ensure that spectrum is allocated to firms that are willing to pay the highest prices. This competitive bidding process often correlates with identifying the most efficient uses of the spectrum, ultimately leading to optimized overall utilization and enhancing the economic value derived from available frequencies. Next, technically enabled sharing spectrum. And technically efficient use of spectrum aims to maximize the utilization of all values of frequencies. And the key measures of technical efficiency include occupancy and data rate, and which assess how effectively spectrum is used over time and how much data can be transmitted per unit of spectrum. And the measure of technical efficiency. Technical efficiency is spectrum use is primarily measured by two factors. What are they? Occupancy and data rate. Occupancy refers to the frequency and consistency of a spectrum utilization over time, indicating how effectively the spectrum is being used during different periods. High occupancy rate suggests that the spectrum is in constant demand and being fully utilized. On the other hand, data rate measurements the amount of data that can be transmitted within a specific bandwidth. Higher data rate indicates a more efficient use of spectrum as it reflects the ability to carry more information without requiring additional frequency resources. Say, for example, 2G, 3G, 4G, and 5G, how we are enjoying in the 5G network. Together, these measures provide insights into the overall effectiveness of spectrum management. Next, spectrum sharing technologies. Several technologies enhance the technical efficiency of the spectrum sharing, categorized into underlay and overlay technologies. Underlay technologies such as ultra wideband WB and spectrum, spread spectrum, which allow for transmission of signal at lower power levels that can coexist with existing user without causing interference. Overlay technology means technologies like dynamic spectrum access, that is adaptable. We can able to change the frequency according to our need, enables high frequency utilization by allowing new users to transmit signal in the same frequency band as existing one with when those bands are not in use. Next, SDR and CR, cognitive radio and software. These advanced technologies allow for dynamic adjustment in frequency usage band based on real-time spectrum availability and user demands. Next, smart antenna other technologies. Smart antennas represent another crucial advancement in technically enabled spectrum sharing. These antennas can dynamically adjust their directionality to focus signal on specific users and areas, thereby improving signal quality and reducing interference. By directing energy where it is most needed, smart antennas enhance overall spectral efficiency and increase the capacity of wireless networks. Other emerging technologies also contribute to this objective by optimizing the transmission and reception of signals, further facilitating the effective use of spectrum in a variety of applications. So, next, coming into the conclusion. The first one is efficient use. Spectral sharing is crucial for making the most of limited radio frequency resources, allowing multiple devices and networks to use the same frequencies efficiently. Next, better connectivity. By supporting the growing need for connectivity, spectrum sharing drives innovations and ensures better wireless service quality and availability. Cost effective. It reduces the cost of deploying networks, making internet and communication services more affordable and accessible, especially in underserved areas. So that's all about the spectral sharing. Thank you for your attention. Hope everyone enjoyed learning about spectrum sharing and its significance in today's digital world. Understanding how we can efficiently use our limited radio frequencies is an important, and as we continue to advance technology and connectivity, your curiosity and encouragement are vital as we explore these important topics together. Let's keep the conversation going and stay connected. Thank you.